In this video, I am going to show you how to graph in Desmos and how to find the equation of the best fit line, which is what you will need to do to be able to do the graph for the second part of the freezing point of salicylate lab, the absolute temperature value. I have some data this is just fictitious data, and I have it on you either have it in your table, you have it on a spreadsheet or whatever, but let's copy it and go to open up Desmos, and I have already named this absolute value. Now you might have this already done in Desmos, but I am just going to copy and paste. And so you can see it already does it for you. It's got all of the values, X and Y, and it graphs, okay, which is what you want, okay. Now you can kind of adjust a little bit of these options here, but not necessary. What I actually want to do is, if you click on this plus and then highlight the expression and then start with y1 and highlight the little squiggly or enter the little squiggly line here. This tells it that I want the regression or the best fit line for the data points that I have. And since it's the best straight line fit, linear fit, if you will, I want the equation of the line to be mx1, in this case, x1 plus b. So I would do mx1 plus b, okay? And you can see that it found it extrapolates, so it constructed the best fit line and it extrapolated to the point where it crosses the x-axis, and that's what I really want. Okay, now it gives you some statistics here. What you really need from this is y is equal to m, which is this, times x plus b. You want the equation of the line, so y equals 0.3025 times x plus 46.32. That is what you want out of this graph that you constructed. Now you can solve that, set the equation equal to 0 because y is 0 at this point, and then solve for x, or if you hover over this point right here, which is where the intersect happens, right, the x intersects right here, my y value is 0 at the x-axis, and this is where it crosses. You can see I have x minus 153.13, and then y is equal to 0. That is the number that you will need. So it will be negative 153.13. That is the experimentally determined value for the absolute temperature. And you are going to take that value and compare it to the literature value for absolute temperature, which is minus 273 and change. So find out exactly what the literature value is, and you're going to compare those two numbers and see how close you got and why you think there might be some error. Now, don't just give me a generic answer, calculations or human error. I don't want to see that. I want you to think specifically about where in my measurements could I have gone wrong and why I have kind of a larger error. Okay, when you are done with this, you can actually save the graph and then copy it into the Word document and submit it that way.